Awesome. So, yeah, this is my talk. It's titled WTF is a Kubernetes and how do I attack it? The joke is that when I first started working with Kubernetes, I had literally zero experience working with it, and that was kind of my mindset was, yeah, I can figure this out, but what is a Kubernetes? How do I go about looking into it? So that's kind of like this talk is going into what I wish I would have known going into that. And then we'll talk about, an overview, a very brief overview of Kubernetes, and then we'll walk through an attack path for a single way that you can compromise a Kubernetes cluster. If you don't know what Kubernetes cluster is, you hopefully will know by the end of this. So that's kind of the agenda. At the end of this, I'll point you to a tool I've been working on that has a bunch of further information that you can go and look at. But yeah, without further ado, a little bit about me. My full-time job is at Google. I'm a red team specialist. I'm on a offensive architecture and advisement team. So we don't necessarily do like consultant style pen testing or anything like that. It's mostly internal things. Recently, it's been a lot of Kubernetes research, which has been great, but it's also, as you'll see, it's a very deep rabbit hole that I've now lots of thoughts and opinions about. Some things about me. I love coffee. I love cooking in cast iron skillets. I could probably do a whole webcast on cast iron skillets and how to cook with them. Tetris, Linux, and I very much dislike Windows, even though I am in Windows right now because I don't trust Windows or I don't trust Linux to get my audio correct for this webcast. So without further ado, part one, WTF is a Kubernetes. So back in the day, there were virtual machines, right? So if you are a company and you are running, some software, right? You are probably doing this on a virtual machine, depending on how long ago this was. The cool thing about a virtual machine is it's very easy to automate, and you can run things like Ansible nowadays. But the problem is there's a lot of overhead with it. If you're trying to run a single, tiny application that maybe is just like an API endpoint or something, you need the whole operating system to do so. And that means you have to maintain, patches. You have to do all sorts of things just to run this single app. It's slow, it's hard to automate, and it, costs a lot more money. And that's the big thing we'll talk about with Kubernetes is the problem it solves is that you can use much less, compute for your application, which in turn saves you a bunch of money because running computers in the cloud at scale can be very expensive. So virtual machines are great. And then we kind of got this concept of containers. Containers are basically the host operating system. You can kind of think of it like subnetting its resources for for each container. So say you have a virtual machine. Within that virtual machine, you can use something like Docker, and you can essentially create a container for every application that you're running. And that container gets its own network namespace. It gets its own host name. It gets its own process ID. Basically, from the view of the container, it's running in a virtual machine, but your kind of host that's running all these containers has visibility into all of those containers. So basically, this allows you to run a single application within its own kind of operating environment, but it's all running on the same VM. So now instead of having a single VM for every single app that you can have a single VM, and each application is running within that VM in a container. So why is that important? Why do we care about that? Other than, it's just cheaper to run containers versus virtual machines. This kind of enables you to do something that it has a bunch of different names, but I think most agreed upon name is microservices, right? So instead of having one big monolithic application for, say your web server, or say you have a website that's running some sort of shop or something like that, you can basically break out each portion of your application into a single container, and then you can run that container basically in a microservice architecture, right? So there's a bunch of benefits to this, right? It's easier to scale. You can just say, hey, I need 10,000 containers to handle this influx of people visiting my website, and you can very easily scale that. I see someone say VM and a VM and a VM and a VM. That's essentially what we're getting at. So it's easier to update each thing because you're not updating the entire application. You're just updating the single functionality of that application. The next things is it is allegedly easier on developers because a developer can say, hey, I'm only responsible for working on the shopping cart. And they have full responsibility of that, and they don't have to interact with other teams very often to make sure that their changes isn't going to break another team's thing. The biggest con is the complexity. This is a very simple diagram of what a microservice can look like. This can have millions of different interconnections between different services, right? So this is a very simple application, but imagine you have something that is, a massive like cloud environment or something like that. There is going to be a ton of different interdependencies with all these containers talking to each other, and it gets very, very complicated. So the solution to that, or at least the thing that we have so far been relying upon, is some sort of orchestration tool, right? So we need some way to orchestrate all these containers and basically manage our application, right? So Kubernetes is a container orchestration tool. Running software just in like a VM or whatever takes a lot of money. And so the good thing about Kubernetes is if you have a good Kubernetes architect, you can say, I only want as much resources available for my application as it takes to run it. And then as soon as that, influx of traffic dies down, automatically deprovision those resources so you're no longer paying for them. So that's kind of like the TLDR of like what Kubernetes is designed to do. It's basically designed to allow you to run these massive microservice environments, and basically, like, I don't want to say it's only to save money, but it is a very good way of optimizing your cost. Now, again, you do have to hire people to run your Kubernetes cluster, and they're not cheap, but it is a pretty cool technology. So the very, very basics of Kubernetes. I will be looking at the chat. I'll be trying to keep up. So if anyone has any questions, please let me know. But the very basic, fundamental unit of Kubernetes is the Kubernetes pod. A pod you can essentially think about as a container for your containers, right? So a pod can have one container running in it, or it can have 50. It doesn't really matter. And basically what you want in your container is everything that your application needs to run. So in this example, we have a web server right here. Maybe this is like an Nginx web server. And every time you deploy that Nginx web server, you want to also have access to a database. And you also want, some sort of security monitoring tool to maybe ship the logs back to a SIEM or something like that. And so this is kind of like the smallest unit that Kubernetes works with. So you can kind of think of it like a Lunchable, right? So everything in the Lunchable is kind of its own distinct ingredient, but you are really supposed to use them all together, right? So we had the Nginx web server, that's like the pepperoni, the dough, that's the security monitoring, the cheese, that's a database, or something like that. I don't know why this is what I came up with in order to explain it, but I'll take it. Also, apparently Lunchables have lead in them now, so maybe you shouldn't eat them, but it's fine. I still like them. So we talked about pods. Pods run on what are called worker nodes. So a worker node is basically a virtual machine that each of these pods runs on. And someone made the joke earlier that like it's a VM and a VM and a VM. this picture really shows that that's very true. So every time you schedule a pod, which is running some sort of service, that pod is scheduled to a node, and the software on the node that's responsible for creating that pod is called the kubelet. So, say I'm an engineer and I say I want a pod with, this web server in it. I would basically write a piece of YAML that we'll talk about in a second and deploy that to a worker node. The other type of node that there is in Kubernetes is the control node. The control node is a special type of node. It is basically the brain of the Kubernetes cluster. And basically what the control node has is a bunch of kind of core components that are mandatory for Kubernetes to run correctly, right? So whenever you're interacting with Kubernetes, you're probably interacting with one of the control nodes. That being said, you can have as many nodes as you like. You can have, say you only want, customer one to run their or have their data on a node that is running in a certain location. You can basically schedule all of their pods to run on a single node. So within the control node, there's the API server. That's where all of the communications to the cluster happens. So if you are interacting with it, you're essentially sending an API request to the API server. etcd is a database that stores the state of the cluster. So Kubernetes will track the desired state that you, the engineer, are saying, hey, I want X, Y, and Z. Kubernetes will track that in etcd. And then the scheduler waits for new tasks, and then it schedules those tasks to the worker nodes. So the scheduler essentially watches etcd. Whenever it sees a change, it tasks the worker node and the kubelet on there to actually go and make that happen. So the other kind of fundamental concept in Kubernetes is namespaces. You might be a little confused because namespaces are a Linux term. This has nothing to do with Linux namespaces. Basically, what a namespace does is it isolates each Kubernetes resource. And again, you can kind of think of it like subnetting within a worker node, right? So you can see down here we have one worker node, which is essentially one virtual machine, and one control node, which again is another virtual machine. And then within this worker node, we have three different namespaces, right? And the point of this would be, say you have a development environment in one namespace, you have a staging environment, another namespace, and you have a production environment in another one. You want your engineers to have access to dev and stage, but maybe only senior engineers to have access to production. You can essentially limit the access that they have. So that's namespaces. Kubectl. There's a lot on this slide, and I promise it's not nearly as complicated as it looks. But Kubectl is the command line tool that you use to access a Kubernetes cluster. When you provision kubectl, it looks in a default directory for this kubeconfig file. This kubeconfig file, you can essentially think of like your AWS access keys, and it has a bunch of other information about like, the certificates, the namespaces you're allowed to access, the resources you're allowed to access. And you basically point kubectl to that config file, and that's how you delineate access between resources. It looks a little complicated if you've ever seen someone using it, but it follows this super simple pattern. So you run kubectl, the verb that you wish to use, and then the resource that you wish to interact with. And then additionally, you can do any flags you want. So down here, you can see, kubectl, the verb is get, and then the resource is pod. And so down here, you can see what that would look like. So in this case, kubectl get pod will list every single pod that's by default in the default namespace. Again, if you want to, provide extra flags, you can do so. So right here, I'm saying kubectl get pod and then -n for to specify the namespace, and then the namespace I wish to specify. So in this case, production. Same thing for kubectl git pod my pod, which is what I'm running down here. That just lists a single pod. There's all sorts of other ones you can do. There's describe to get more verbose information and some of the logs that are in a pod. You can get the namespace, and you can also write the shorthand for these. So kubectl get namespace. You could run kubectl get PO, and that would get pod. So you can kind of shorthand them if you want. So the next big thing, this is where security comes in, role-based access control. So role-based access control allows you to explicitly define what is allowed and then deny all other privileges, right? This is what you use mainly to implement least privilege, right? So role-based access control is kind of like the big thing that you want to get right from a security perspective. And role-based access control can also be assigned to principals, right? So if you have a container, say your container is a, say some sort of web server, you probably don't want that web server to have the ability to create pods in your cluster. Like it just probably doesn't need that, but it may need access to some sort of secret. Maybe it's like an API key or something like that. And so this kind of YAML over here is how you would define that. So in this case, we're saying we're going to create a role and we're going to call it pod viewer. And we're going to assign this role the get and list verbs or actions, which somewhat corresponds to the kubectl commands. And basically on this resource pods, so the only privileges that this pod will have in our cluster is it will be able to get and list the pods that are running, which isn't like a huge deal, but this can get super confusing, right? So remember how I said it somewhat related to it. This is where things get super, super complicated and it's really hard to follow. So if you run kubectl get pods, it will return a list of all the pods running in your cluster. You would expect that this get verb would grant you that access because you're typing get pods. When in reality, if you want to get multiple pods, that's actually a list verb. And this is one of my gripes with Kubernetes is there are situations where things like this pop up all the time where you say, hey, we're tracking who can get, XYZ resource. We're maybe logging that, but we're not logging who can list the resources, which is just as bad, if not worse. So there's all sorts of little like inconsistencies with things like this that isn't super intuitive, but we'll get into that a little bit more in a second. So when I was first starting with Kubernetes, I wanted someone to just say like, this is what like the workflow would look like. And essentially that's kind of what I've mapped out here. So step one is, an engineer writes a manifest. This is just a YAML file. You can name it whatever you want. And in that manifest, they say, we're going to create a pod, and then we're going to name our pod my Nginx pod because we're running a web server. And then within that pod, we're going to run a container named Nginx container. And then the image that we're going to use for this, which is essentially like if you've never worked with, Docker images, it's essentially like almost think of it like a Linux distribution that you're going to be running. So we're going to pull the latest Nginx container. So the engineer writes this manifest and saves that to a file. And then they run the kubectl command where they say kubectl apply -f for the file, and then they pass in the file name that they just wrote. What happens next is the API, the kubectl command line tool will make an API call to the API server. And this is where any authentication or authorization happens. The etcd database is now updated with the engineer's request. The engineer says, hey, I want to run this Nginx web server. That is now stored as the desired state within etcd. The scheduler then says, hey, I've noticed that there has been an update to the desired state. And it basically tasks the kubelet that's running on the worker node with the the information it needs to start this container. So that's basically like the full workflow. It goes from the API server, the database of the desired state is updated. The scheduler notices that it is updated. It tasks the kubelet, which is just the service running on the worker node, with the instructions on what to do, and then the kubelet starts that pod. So that's it. That's like the very like most simple workflow. Now we get into the fun part. So I've been doing a bunch of research into secrets in Kubernetes. So you can almost think of Kubernetes secrets as a like a credential manager within Kubernetes. And the reason that this is necessary is, say you have a container that needs access to some sort of database. You don't necessarily want that container to have that database password hard coded for a bunch of different reasons. But if it ever changes, that's kind of harder to rotate. There's a whole bunch of reasons you don't want to hard code your credentials, right? So secrets is good because it lets you store them in kind of like an external area where they can be changed. And then every time they're needed, or every time a pod is created, it will basically get that secret injected. The thing to notice here is, if you look at this username and password is base64 encoded. So you could go ahead and decode this. There's no encryption on the actual secrets. The whole point of Kubernetes is it makes things very easy to run in like an infrastructure as code repository. So you commit all of your configuration files to a repository, and you can now redeploy that infrastructure very, very easily. The problem with this is now you're committing secrets to a infrastructure as code repository like GitLab or GitHub or something like that. So this is already a problem, because you can't see the credentials here, but it's very easy to reverse because it's just base64. So whenever a secret is needed by a application, the engineer writes the manifest for say Nginx, say it needs to access an API key. When that pod is created, this secret right here is mounted into the pod as a Linux environment variable. And then now your application can access that secret without having to do anything extra. You don't have to change the configuration of your program to run in Kubernetes. As long as your application knows to read it from a environment variable, it will be able to access it. So I said that I've been doing a lot of research into secrets. We don't have time to get into all of it. I really could do like, a 10-hour long webcast on the issues with secrets. But basically, I'm not a huge fan of them. I think that they are fine to get started, and they're better than hard coding credentials. But there are tons of issues that it seems like almost no one talks about. And it's just kind of like the industry standard to use them, because there's no better solution right now. Or there is, but it's very, very expensive. This kind of graph that I made is basically just kind of a back of the napkin math on all the different ways you can access a secret. I'm sure there are more ways that I have not documented here, but you can already see that there's a lot of different ways that secrets can be accessed. And, doing some sort of logging is not going to catch every way that you can access a secret, which is, kind of a problem. So speaking of logging, if anyone has ever had the privilege of working with Kubernetes logs, you will know that it is a huge pain. And logging Kubernetes is great to the point where it gives you so much information that is just way easier to not deal with it. Like, just assume compromise, assume everything's bad. Basically, if you turn on logging at like the metadata level, you will get hundreds or terabytes of logs every hour, depending on the size of your environment, which is fine. But if that's for like a small environment, if you have a large environment and you're logging at a higher than a metadata level, you will just be like inundated with all types of logs that you have no idea how to parse. So that's great. you have all these logs, but even if you have all the logs, it doesn't necessarily make sense, right? So this is kind of how you define what Kubernetes logs. So you can see right here, we're logging at the metadata level. We're going to log every time a pod, because we're specifying that with the resources, is created. That's cool. What does that mean? I don't know. Is that bad? Probably. It depends. If you are a SOC analyst and you don't work with Kubernetes, you're not like a Kubernetes engineer, every log literally just looks the same. So over here, we see that we have a new audit policy and it says, hey, we're going to log every time someone runs git secrets, right? That should be good. Every time someone accesses a secret, we should have a log for that. Is that what this policy says? No, not at all. This is only logging if someone runs, kubectl git secret. If I were to run kubectl git secret, kubectl git secret my secret, that would be logged by this. That's good. If I were to run kubectl git secrets, where I'm just listing every single secret, that's not going to be logged by this audit policy, even though I'm running kubectl git secrets. So it's super, super confusing. How do I log Kubernetes cron jobs being created, which is essentially like a one-time execution of some service. It's basically the same as a Linux cron job. You would say, the verb, I want to log every time a job is created. That's how you'd log that, right? Nope, it's actually the verb is create pod, because in the backend, Kubernetes is creating a pod to run your one-time job. But, just writing kubectl create job, that would not log that. So that's wonderful. Anyway, Kubernetes logging is ridiculously complicated, and a lot of the information out there on it is wrong. And there's just some things that don't exist on the internet. Like, how do you log certain things? You just have to figure it out yourself. So it's fun, especially as a red teamer. So with that being said, that's like the very basic like TLDR of how Kubernetes works. That is probably not enough to start working with Kubernetes. You really just need to get access to some sort of cluster. You can use technologies like Minikube or whatever to go through and basically practice creating resources, listing resources, creating secrets. But what everyone is probably here for, how do you actually hack a Kubernetes cluster? I have the Discord pulled up, so if anyone has any questions over the previous slides, please let me know. I'll be looking at that for a few minutes now. But let's get into how to hack it, right? So step one, just like any pen test, is you're going to need to get some sort of initial access. This is very dependent on the environment that you're working in. You can be running in some sort of cloud environment. You can be running Kubernetes clusters essentially on-prem, or you're hosting them yourself. So very environment dependent, but the best ways that I found is you can either, phish developer credentials, right? So say you are doing an assessment for an organization, you get in via phishing, and you realize that you're on some developer's machine who has access to a Kubernetes cluster. That's a great way to do it. Finding access to a kubeconfig file, right? So remember we talked about how this is very, very similar to a AWS like access key. If you have this file, you are basically, that is your proof that you are this user. So keeping those safe is super important, super hard to do, and it's super powerful if you can find that as a pen tester or red teamer. The next, and probably I would say most common way to get initial access is command injection or remote code execution. Remember how we talked about how a Kubernetes pod is essentially just running a service, right? So if you are say, running a web application that has some sort of command injection vulnerability that I, as a pen tester, have found, I can exploit that to get a shell on the container that is running that web server, right? So this might look like you go to the website, you find a command injection vulnerability, you know, upload some sort of web shell or get, you know, some sort of reverse shell. You are now within that container in the Kubernetes cluster inside the pod. So that's probably the most common way that you will find yourself inside of a cluster. So the next way is you can compromise a container image. We see this a lot with like Docker images, right? So if you are pulling your container images from something like Docker Hub, you want to make sure that the images you are pulling are not, you know, pre-compromised, right? So you can almost think of this like if you are downloading a Linux virtual machine and say you just download Ubuntu, if that Ubuntu image is already pre-compromised, there's not much you can do. The same idea with container images. If that container image already has a piece of malware in it, that's how you can be compromised. Finding publicly exposed internal interfaces. This is actually how Tesla was hacked a few years ago at this point, is they had a Kubernetes dashboard that allowed them to kind of manage their cluster. They had that publicly exposed. And so someone found that and ran a bunch of crypto mining software on all their infrastructure, which is kind of like a lame attack. Like if you have access to a company's Kubernetes cluster, there's so many cool things that you could do. And the fact that they only deployed like a crypto miner is kind of lame, but it is what it is. So let's assume that like I, as a pen tester, am doing some sort of assessment for an organization. And, you know, I've identified that the application they're running within their Kubernetes cluster is just a web server. I have identified that the web server that they're running, the service has some sort of command injection or, you know, RCE or something like that. That's kind of like the starting point, right? So this would be my initial access. I have some sort of shell access to this container that's running on this worker node, which is probably running in their, you know, cloud provider or on-prem or something like that. So I now have shell access to their Kubernetes pod. What do I do now? Like I am in a Linux environment. I'm in their container. What good does that do me? So the first thing that you should do is you should check for service account tokens in these directories, right? So if you, depending on which environment, which cloud provider, or if they're running on-prem where they have some weird custom solution, checking where the service account authentication information is within that pod is usually my first step. So run secrets kubernetes.io/service account. That directory will have a few files that will basically allow you to impersonate the pod that you're running. We'll talk about that a little bit more in a minute, like why is that useful? But the next thing you can do is check the environment variables for sensitive data. If you remember back to when we were talking about Kubernetes secrets, whenever a pod is deployed, if it's configured to have a secret, it will by default end up in the environment variables of that container. So if you just run, you know, a env command, you can look through and see if there's anything that's called like, I don't know, access key or SSH token or whatever. So that's always a good place to look. The next thing you can do is within your container, you can check to see what files you can access, right? So if there is a volume mount from the node, and what that means is basically there's a directory on the control node or the worker node that you have read-write access to. There could be some sort of, you know, sensitive information there. You might be able to write files. You might be able to steal files from that. We'll talk about that a little bit more in a second. This is kind of what that looks like, right? So you can see I've just ran the env command and I'm grepping for cube. The -I says that I'm doing a case insensitive search. And you can see that indeed I'm running in a Kubernetes cluster because these kind of default environment variables are set, which is kind of giving me some situational awareness. We can see in the var run secrets Kubernetes service account directory, there are 3 files. Each of these files has its own use, and we can basically, if we can get kubectl into the pod, because the pod probably doesn't have kubectl in it by default. So basically we upload kubectl, and then we run this command auth, and then cani -- list. This is basically going to give you a list of every single verb and resource that you have access to. So we are impersonating the service account of the pod that we're in, right? And in order to do so, we have to specify these different commands for kubectl, so it knows to use the service account information for the pod that we're in. So we do -- token, and that gives us, we basically ingest that from this this file right here, the certificate authority for the cluster, and then the namespace that we have access to. And then once we run this kubectl auth cani -- list, we get this output down here, and it says, hey, these are the resources you have access to. These are the actions that you're allowed to do with those resources. And so just looking at this, like if you know anything about Kubernetes, these are very dangerous permissions to give to a service account, right? Essentially what this is saying is that the service account I'm running as has access to create, get, watch, and list different pods in the cluster. I have access to attach and exec into those pods. And we'll see why that's dangerous here in a second. So this is kind of the point that we're at now, right? We have shell access to this Kubernetes pod. And we've enumerated it to basically say, oh, we have found, role-based access control that is overly permissive, right? And this will allow us to escalate onto the worker node itself. And basically the end goal most of the time for me is if I can prove that I can get from a pod to a worker node, that's normally the end goal for me, right? Because I have now demonstrated that I've pivoted from a external, web app interface into a container into the actual Linux infrastructure. So that's usually the end goal of what I'm trying to access. So at this point, we have to say, okay, we can either try to move laterally or we can try to escalate our privileges. To move laterally, all the normal Linux pen testing things are in scope. You're seeing what can you reach from this kind of foothold? What does the service account that we just talked about allow us to do? Can we do things like ARP spoofing? Can we sniff between the different services? Can we look at those packets? Oftentimes in clusters, if they are not super mature, they do not have TLS enabled by default. And that's a huge issue because if I can sniff the actual packets going between each container in the cluster, I may be able to scrape sensitive details from that. I will probably at some point be doing a blog post on how to get this working. It's not super intuitive. You can't just run TCP dump on most things, but there are tools out there that will allow you to do this. Again, it's a normal pen test at this point. Can you access cloud credentials? Can you find any secrets within the container that will allow you to maybe get access to a different container? Or can we do some sort of privilege escalation? This would look like spawning a privileged container, abusing role-based access control to, maybe the container service account that we have access to is allowed to list some sort of secret that is maybe an SSH key to the infrastructure or something like that. Can we abuse any of the mounts that are in the Linux container from the node. We'll talk about how that would work here in a second. Again, you're probably running in a cloud environment, so can you do things like access the instance metadata service and pull back some sort of credentials from that? It really is just like another layer on top of like a normal network or cloud pen test. So in this case, we have identified that the role-based access control assigns the pod that we are in is overly permissive, right? And we're going to use that to abuse the host path mounting feature of Kubernetes. So again, this is kind of what we identified in our enumeration phase. We found that, hey, if I impersonate this pod, I can run, or I can create, get, watch, and list the pods in the cluster, and I can attach and exec into them. That's a super dangerous permission, and you'll see why here in a second. So we still have shell access to this pod, and it has overly permissive role-based access control that will allow us to create a pod. So how do we do that? This is the shell inside of that web application pod that we have we have access to, right? So I have written this Kubernetes manifest file, and I've said, hey, I'm going to call this pod the pwned pod. Within this pod, I'm going to create a directory that is just called root file system. This could be named whatever you want. And within that directory I've just created, I'm going to create a host path mount. And what that's essentially doing is mounting the root of the node file system that our container or our pod is running in. And it's basically going to mirror the node's file system into this root fs directory. And because I have those permissions to create a pod, I'm allowed to do this. So if I save that file and I run kubectl apply -f and then the pwned.yaml, which is what I named this file, and then I also specify these different tokens, right? So I can actually impersonate the pod that I'm running in. You see down here, it says, the pod pwned was created. That's super cool. So let's see like what happens there. So the point that we're at is we have identified RCE or command injection into this Kubernetes pod. We've identified that it has been permissioned with role-based access control that is, probably a little dangerous. As the attacker, I'm abusing that by spawning a pod on the node that we're running on that's going to mount the file system of the actual host. And so now I have access to like the host file system. And that's kind of game over. There are different things that you might want to access, but for the most part, like this is usually far enough to where people are like, okay, yeah, this is really bad. Like you are now on Linux infrastructure that no one looks at, to be honest. So to actually like execute the attack, we just created that pod and we called it pwned. We're running kubectl exec, which is essentially, you can almost think of it like SSHing into the pod. We're running -it, so we have an interactive terminal. We're specifying the name of the pod that we want to exec into, and then we're just specifying right here that we want to run sh. So this could be bash. We could run shutdown if we want to, shut down the pod or whatever. And that gives us a shell into the pod. You run who am I and host name, and it says we are root, and we are in the pod with the host name of pwned. Now, remember the actual like attack that we did was we mounted the root file system of the like Linux infrastructure, the node that we're running in. We put all those files in here. It's essentially being mirrored into this file. And so if we run the cat command, we say cat root file system, and then etc hostname, we can see that now we're getting the host name of the actual name of the node that we're running on. And so at this point, we can basically do whatever we want. We can, set up a cron job that maybe kicks off some sort of persistence. We can maybe have a SSH key that we upload to the root directory. So now we can SSH into the node, really whatever we want to do. We also have access to this Etsy Kubernetes manifest folder. Any file that you put in this folder that's a valid Kubernetes YAML file will immediately be started by the node, right? So if I put a file in here that's called Graham's web server.yaml, as long as that YAML is valid, the Kubernetes cluster will just automatically run it, no questions asked. It's called a static pod, and it's how the etcd and the Kubernetes API server, it's how all those are started. So that's super fun. And that's basically like you now have root access to the Linux infrastructure that's running the Kubernetes cluster. And from there, you can do whatever you want. If you want to, go further and demonstrate even more impact, you're no longer doing Kubernetes pen test. You're now doing like a Linux infrastructure pen test. So is that it? Like, do you win? Yeah, like you have access to Linux infrastructure, and no one will find you because no one actually understands Linux infrastructure. There's like 5 people in the world who do, and they're all really, really busy. And so, yeah, that's basically like all you need to do to get access to that infrastructure. Are there any helpful tools? Absolutely. So there's some great projects out there. Microsoft has a Kubernetes threat matrix, which I relied heavily upon for the tool I'm about to show you. There's Trivy by Aqua Security, and it's not just a Linux pen testing tool. It really is like a suite of tools built into one that can help you with a lot of other um, issues that you might run into, right? So like container scanning, all that sort of thing. Trivia is really, really good at helping you hunt down those vulnerabilities. Paraties by Jay Beal is basically the Swiss Army knife of Kubernetes pen testing. There's all sorts of functionality in there that's super, super useful. There's Kdigger, which is you can almost think of it like LinPeas, but for Kubernetes, although LinPeas does have a mechanism where it will say, hey, you're in a Kubernetes pod. Here's all the different things that you should look at. Dredge, which is a tool I will show you here in a second. I actually wrote it. I wrote it in Bash, which is probably not the best thing to write something in nowadays if you want it to go quickly, but it works really well. Dredge will essentially let you do a couple of things. The main things for Kubernetes is it has a -K option. If you run that, it will essentially search your entire file system or whatever path you specify for Kubernetes kubeconfig files, right? So if you have access to like a developer's machine, you might want to run something like this that you can say, oh, there's this admin.conf, and this is a admin kubeconfig file that I can use to access the cluster and do nefarious things. So there's that. It's not like the world's most well-written tool, but I use it constantly because it's super simple and it works pretty well. So the other thing that I've put together is a resource that I call the CubNomicon. So shout out to my sister who designed this sticker. I actually ran out of stickers, so I need to print some more. But the CubNomicon is essentially a threat matrix for Kubernetes that's offensive security focused. So I mentioned how there's the Microsoft threat matrix for Kubernetes. The problem with that is they explicitly say this is not to teach you how to do these attacks, which is a problem for me because that's literally all I wanted to know is how to do the attacks. So I've set this up. It's just CubNomicon.com. You can go explore it. If my switching tabs works, we shall see. It does not, but just go to CubNomicon.com. This is basically what it looks like. It's every single thing that we talked about in this presentation and like 10 other ways you can compromise a Kubernetes cluster. It's essentially all of my notes on how to do this. Let's see if this works. Hopefully y'all can see this. Basically, you just come here and there's a threat matrix, which I pulled from Microsoft. I tweaked to my liking. And you can basically come in here and say, hey, I want to know, how can I backdoor a container? You can come here and this is all my notes on how to backdoor a container and how to defend against someone backdooring your container. There's a bunch of different things in here. There's lots of things that I have yet to add because I just have not had time, and there's so much stuff to do with this. But there's different walkthroughs of how you can execute these attacks, what the defenses are, and all the things that you should be aware of. So go check that out. If you want to do any sort of contributions to it, it's all open source. It's just in GitHub. There's a little guide on how to contribute to it. But the main reason that I wanted to do this webcast was because I feel like Kubernetes is at a place where Active Directory was like 10 or 15 years ago, where people just like ran it and they're like, oh, it's fine. It's like secure by default. Um, that's clearly not true. I don't know if anyone has worked with Active Directory recently, but it's like no one is even looking. Well, I shouldn't say no one. Very few people are looking at like the infrastructure that's running like most cloud, um, startups or software or whatever, because it just kind of works, and no one has really like taken the time to go into all of these different services that are needed for Kubernetes to run. Literally just yesterday, Mandiant published, this crazy privilege escalation in Azure's Kubernetes service. And like that's probably existed for a very, very long time. And it's because there is like very few people actually looking at it that makes me really want to look at it, because I feel like there are so many things out there that like no one has found, just because no one's, looked. And there's so much prerequisite knowledge you need to even start like understanding these things. Like if you're looking at I know you can't see this very much, but if you're looking at like a service mesh like Istio, that is a very like convoluted technology to look at. And that means that there are very few people who are like qualified to look at it. And there's just too many things for the few people who are qualified to look at it. There's too many things for them to spend their time on. So if you really want to like go find some cool vulnerabilities or some cool bugs, just look into any of these projects at landscape.ncf.io. These are kind of all the cloud native services that are being, they call them incubated by the Cloud Native Foundation. And it's all these services that are running kind of the organizations that we're working with. And so it's a gold mine. Like you can literally just pick any one of these and go research it, and you'll probably find, some sort of security issue with it, which is amazing and also terrifying. That's all I have. I'm very surprised I got through like all 50 slides on time. If there's time, I'll stick around for a little while if there's time for Q&A. CubNomicon.com. And if you want these slides, you can just go to my GitHub, which is github.com/Graham Helton/slides. I don't know if there's any time, but if there is, I'm happy to answer any questions that you guys have flagged in the chat.
For sure, dude. Thank you for being here and sharing your knowledge with us, man. It's
Yeah.
always appreciated. Love it. I mean, there's quite a few questions that we have from like the Zoom chat. I'm sure there was even more in Discord. But we could try to get through some of them if you got time, for sure.
Yeah. Yep.
All right. I'm gonna have to scroll through some of them. Sorry. How can one manage a secret securely and be integrated with our Kubernetes environment?
That's a good question. And if I had the answers to that, I would almost certainly start a company and sell it to you for lots of money. No, I'm just kidding. There are lots of ways that you can increase the security of your secrets, right? Like just putting them all in the Kubernetes secret manager is a great place to start, but just know that there is an increased attack surface there. And so you really just have to figure out like what can your organization afford? There's a bunch of vendors that will do this for you. I think it's way too expensive. There's also like some open source software that helps with these. The one that I really like is Bitnami sealed secrets, which will essentially it will encrypt the files that you are committing to your infrastructure's code repository. So before you commit a secret, it is encrypted, and then it goes to your repository and stored in a way where someone who has access to it can't necessarily know the secret. And then at runtime, it is kind of decrypted for you. There's other things. There's like HashiCorp Vault. But again, like these all get really expensive. And I really wish that there was a piece of open source software I could recommend that was just like a secret manager. I have not found one. So if anyone knows of one that is open source and free and works well, please let me know.
Awesome. Thank you, dude. You may have answered this in one of your slides, I'm not sure, but what is the difference between microservices and API and containers?
So microservices are, let's see, it can get complicated. So an API and a container is its own separate thing. A microservice or a microservice architecture is essentially all of your application is running these containers and APIs in a very specific way. Essentially, you are running it. How would I describe this? You're running your application out of containers. Those containers probably use APIs to communicate to each other. Those two things, kind of combined together, are what give you like a microservice architecture, if that makes sense.
I think it did. Oh, dude, I love you. I'm so glad that you're here to be the expert.
The expert.
You're the expert, and you're like
Wow.
learning, it's like you're trying to explain explain things, and it's like a process that you're trying to make sure, like, is this right? Am I describing this correctly? And you're like testing your knowledge at the same time. So it's like a
Right.
cool learning experience for you.
I will say it's a little odd because like I don't do Kubernetes. Like I'm not like a site reliability engineer. Like I don't set up Kubernetes clusters. Like the only way I know of it is from attacking it, which is like a very skewed perspective to like view things from. Um, but it's fun.
Always looking at it. How do I break you? How
Yeah.
do I exploit you?
Yeah.
Gotcha. Lots of devs using Kubernetes don't think they need many security controls around containers since they can easily be destroyed and redeployed if exploited. What is your take on that?
Um, yeah, but that's not going to stop someone from exploiting it. Like your defense from being exploited should not be that you can just restart the container. Um, the first thing I'm going to do is, try to get onto Linux infrastructure. And I'm not necessarily trying to, my end goal is not to get into a pod. It is to break out of the pod somehow and get into like the Linux node. And at that point, I'm going to be super hard to catch. So the pods are really just like an entry point to, bigger and better things. In terms of like, is that a good security measure, just restarting it? Like, yeah, that's fine if you know when to restart it. But if you knew when an attacker was in the first place, like, you could just fix it there. But that's the problem is you don't know when someone's going to attack or when someone's going to find, command injection or, remote code execution.
Thank you, sir. Is it common for a pod to be able to mount read and write of the worker node? Is that a permission that can be set in Cube?
Um, so I wouldn't say it's common. But what is common is all the different attack paths that I've laid out in the CubNomicon. What really gets people with Kubernetes is it's complicated to make sure that your application has all the correct permissions. So people just give it all the permissions. They literally write in the pod manifest or the role that's assigned to the pod. Just give it all the permissions for all the resources because that's what works. And actually, like going in and fine tuning, saying, "Oh, my database pod actually doesn't need to access secrets. Like that's just not something it needs to do." That's really what like a pen tester should point out. but by default, like a lot of people just need it to work. So they just, assign all the permissions.
I love this question right here. Is how do we get more people understanding Linux to avoid issues that you've highlighted today?
That's a good question. I don't know. I always push people down like the Linux rabbit hole because that's kind of the rabbit hole I went down, and it's probably one of the most like beneficial things I've done for my career. Um, like I run Linux as my main operating system. I set up lab infrastructure all the time. Um, and having a good understanding of Linux is like it's weird, but it kind of makes you like a unicorn because so many people I find especially like pen testers are very, very focused on like Active Directory because that's what they're seeing in like client networks is, oh, hey, we phished someone and now we're in a Windows environment and we got domain admin. They don't even need to touch like the Linux infrastructure. Um, so if you do understand the Linux infrastructure, like it is way more appealing. And I think it is like probably one of the best things you can do, especially like first starting out, is like run these or understand how Linux works. As far as like how to convince people of that, I don't know. I wish more people would spend time on it, but it's hard to do that when everyone is so focused on Windows and Active Directory right now.
I'm gonna do a shameless self-promotion here, because in a couple weeks on September 5th, Hal Pomeranz is doing a pay what you can, zero to Linux workshop. It'll be a 4-hour workshop. Starts at $0, so y'all can come and learn Linux. And Hal is like an absolute legend. So definitely at least check it out. Like I said, it's pay what you can, so you can join for free, but you will learn the fundamentals of Linux for sure. So
Yep. And that's the
sorry,
other
shameless
thing.
self-promotion.
No, that's the other thing with Linux is like there is always things to learn about it because there's a bunch of different variants, right? So that's always interesting to learn about. And then there's also like there's so much history with Linux to learn about from people like Hal. So I'm moderating for his class in Wild West Hacking Fest,
So
and
cool.
I am so excited for that because it's more of like an entry level class, but like it's Hal's entry level class. So it's going to be like you're just going to be like a fire hose with all this amazing information about Linux. I'm super
Yeah.
excited for it.
I'm super stoked for this workshop. Like I'm actually going to attend it and sit down and do it
Hmm.
because like it's been a while since I've been in like a Linux OS, so it'd be nice just to get like a refresher, but obviously like just to learn from Hal because
Right.
if nobody knows who Hal is, we've done a lot of different like webcasts with him, so you could definitely check back on the YouTube channel, but he's just like an absolute gold mine of like information and he's just such a nice genuine dude. So
Hmm.
fun learning experience with him. So I know there's a few more questions here, but
Sure.
what's the best way for people to get a hold of you if they do have more questions? You want to throw your slide back? There you go. Ryan, I think probably threw it back up. Perfect.
Yeah. So my website is where I post most of my things. grahamhelton.com/links has links to all my various social media and stuff like that. I would say like just ping me in Discord. That's probably like the easiest way to. Or if you're watching this later on YouTube, just message me on Twitter. It's at that link. That's probably like the best place. I check LinkedIn occasionally. Um, I get some crazy LinkedIn messages though. So I don't check it
Sure.
very often. But I will, if you reach out to me on any of those, I will eventually get back to you.
Definitely check out Graham's blog as well. So I want to share this with everybody because for
Sure.
many, many years, I've known you, been familiar with your work and what you've been doing even before working here at Antisyphon. And I think I have recommended your blog to like more people than I could obviously ever count. But like yours is the top blog that I constantly refer people to as like setting an example of what you can do to kind of put yourself out there and just like and helping yourself and just learning more knowledge and putting like documentation and blogs together. But just being able to share that knowledge with everybody else as well. And I
Yeah.
genuinely appreciate what you do. I just want to say thank you for that, because you have been like an invaluable resource for me to refer people to, because of, the example that you set for the industry. So I appreciate that, man.
No, I really appreciate that. I don't know. I feel like my blog is like one of those things where it just started out as like I wanted something to put on my resume. And now it's just kind of like Linux. It's one of those things where I tell everyone to do it because like I have a bunch of certifications. They have not gotten me a single job. I think the thing that like most people have gravitated towards is like, oh, I've spoke at, conferences or webcasts, or like they're like, oh, I read your blog. Like the one thing you need to do in security is like do technical things and you need to talk about them. And that's kind of what a blog shows that you can do. And like just for my own reference, like I reference my own blog all the time, like especially my SSH one on how to do like SSH tunnels. Like it's just a good like public resource that you can reference yourself to, which is super, super useful. But I really appreciate you sending people that way.
Of course, man. Always. I always will. I cannot express my gratitude and appreciation enough for you and what you do. I, again, genuinely appreciate you sharing your time with us and everybody else, and your knowledge, man. It's greatly appreciated. I just
Yeah,
want to
no.
highlight really quick too. Michael Allen and I just had this conversation yesterday, where he was saying, dude, I still go back to my slides in my class, because there's different commands and things that, I just don't remember off the top of my head. So I need to use that as a reference. And I do
Yeah,
the same thing with like Active Directory. Like I have like a video, like a couple videos on YouTube that are like, 6, 7 years old. And I still refer back to those to walk me through the setup process, so I know that I'm doing it right.
yeah. It
Cannot,
like
yeah,
forces you to document like the things that you're working on in like a way where you like you can write like very quick notes, but if you come back and look at your notes like 6 months later, um, at least for me, I'm not going to remember what I'm doing. But if I actually wrote a blog post explaining to someone how to do it, that someone is probably going to be me in like 6 months. So it's useful for other people, but like it's also super useful for me.
100%. I love that, man. All right. Again, thank you for being here. For everybody here who's still sticking around, we are going to be starting our breakout room here in just a couple seconds. So if you have the Zoom application installed on one of your devices, the bottom of the screen, you should see breakout rooms, and we'll start the AMA there in just a moment. But if you are not joining us there, we hope to see you next week for our next Anticast, which will actually be featuring Hal Pomeranz. So hope to see y'all there, because I know we'll be talking about Linux. So thank you all again. Thank you, Graham, for being here. And I hope
Hmm.
you all have a good week. And I'll see you soon. Take care, everybody.
Awesome. Thanks, everyone.